Hello and welcome back. Let's talk about line integrals over vector fields. A line integral over a vector field is denoted by this notation, the vector field f dotted with our small term in R, which is also a vector. And how we can evaluate this is, of course, parametrize C into a function R of t. We now have our vector field represented in our parametrization form. And then we're going to dot product it with dr over dt. And then we're going to evaluate that entire integral with respect to t. And so now you see why this is vector calculus and not just multivariable calculus. We were just talking about multivariable calculus for the past few videos, but now we have gotten into vector fields and how to evaluate integrals over them. So I think we should just hop into an example to see how this might work. Our example is the vector field, which equals x, y. You could also write this as x I hat plus y j hat. You may see these in both forms depending on what type of vector calculus you are taking or studying. Okay, now we need to know what c is. We'll say that c is the portion of x squared from 0 to 1 on the x-axis. There is c. So let's parametrize c. We can represent it in this form. X equals t, y equals t squared. If we really wanted to, we could just replace x with t, or t with x, and we could very easily see why this parametrization works if you were confused with how I come up with this parametrization so quickly. Okay, so now what do we need? Well, we need to represent f in a form of R of t. And that's just going to be t and t squared. Very easy. Let's find dr dt. This is very simple. We just take the derivative with respect to t of each segment of R of t. So this is still going to be a vector. The vector is going to be 1, 2t. Now we must dot product these together to get a scalar so that we can actually evaluate this integral. Okay, let's just do this. T times 1 is t. 2t times t squared is 2t cubed. Very simple, very easy. Okay, well, what does t run from? Well, x runs from 0 to 1, and x is just t, so t runs from 0 to 1. So we can now rewrite our integral as the integral from 0 to 1 of t plus 2t cubed dt. This is a very, very simple integral. It's going to equal 1. Now, I'm going to assume that we all have enough knowledge on integrals to evaluate these ourselves. But if you do need to refresh yourself on integrals, I have many videos on those. This would be part of our Calc 1 series. So thank you for watching this video. I hope this helped you with line integrals of vector fields, and I hope to see you in the next video where we talk about surface integrals, which have a much more awing application to real life.